Hey everybody and welcome back to the channel. I was wondering if anyone amongst you can tell me the difference between these two items here. Because the fact of the matter is that my Synology NAS isn't what it used to be anymore. The only thing it seems to be doing is flashing this blue LED of death. So we're talking about my Synology NAS here that underwent a power cut, and as a result of that, the only thing it's doing now is just displaying this blue LED, which is constantly blinking. And that's a bit of a shame because this Synology contains not only all of my YouTube video files, projects, but also family pictures, the whole shebang. And despite the fact that it does turn on and I hear the fans spinning, all it does is display this blue LED here on the power button. The hard drives aren't really spinning and I can't access the damn thing anymore. So yeah, there's obviously something seriously wrong with it, and the only thing that happened is that there was an accidental power cut, so the NAS isn't configured to turn on again automatically as soon as the power resumes, so I had to manually start it up again, and then I noticed that this blue LED was blinking constantly. And for the rest, there was just no activity here. So what do we do in a situation like this? Well, first thing, we are not going to start panicking. We're just going to be shutting down the machine and see what we can do. I went through the websites and went through the manuals, and there is a sort of a troubleshooting guide that you can go through. So let's start with that. So I turned off the machine, and the first thing I did was remove all of the discs which were included here. There are 4 discs included here, 2 Western Digitals and 2 Seagates. They are mirrored in pairs. So this gives me an 8 terabyte storage facility here. But, you know, despite the fact that I removed the drives, the unit still wouldn't turn on. I still had the blue LED of death. So here you can see the 4 SATA connectors here for the hard drives. And as soon as I turn it on, the fans spin up briefly. It seems like the machine shuts down again, and then it starts again. But I kept this on for like an hour or so, and the only thing it did was keep the fan spinning and keep the LED blinking, so definitely not good. On the back of the unit there is this small reset button that you can access with a paper clip, so I went ahead and did that, but the machine just didn't respond at all to it. It just kept on running. And I even noticed that after trying to reset the thing, I wasn't able to turn it off by pushing the power button. So I had to turn off the machine by cutting the power. Now this is a Synology DS918 Plus. It's one of the more expensive models, around $500 US, but it's also 3 years old, so I am out of warranty. So I'm on my own. Either I can go out and purchase a new NAS box, or I can try to fix that one. Another thing that the troubleshooting site also mentions is that there are 2 M.2 SSD slots here, and if you have an SSD card in here that you should remove it, but I don't have any, so that can't be the issue. Later on I also noticed that there is a debug port here, which I didn't notice at first, so I didn't really took any attention to that. But so yeah, here I am with a dead NAS box. So as any good technician would do, I attempted to open it and see what we had inside. So there are only 2 screws which are holding the chassis in place, so it's just a matter of unscrewing these 2 screws and then we can get the chassis off. So yeah, the machine had been running for 3 years constantly, so there is a little bit of a dust buildup here, but it's not that bad. And besides the plastic chassis, all we have here is a big chunk of aluminum to hold the 4 hard drives, 2 fans, and a PCB hidden away somewhere, which we will try to access now. So let's start by unscrewing a couple of screws to disassemble the entire thing. So yeah, here we have the main PCB and the aluminum with the 4 SATA ports to hold the hard drives. We have a coin cell battery here, we have a speaker, we have the main CPU, which is an Intel Celeron CPU. We have some flash storage here, which contains the DSM software, the disk station management software. On the other side, we have the 2 M2 SSD drive slots. What else do we have here? We have a 6-pin connector here, which appears to be some kind of debug port that we will also take a look at. Here you can see the 2 M2 SSD connectors. So this basically allows you to hook up 2 SSDs for faster storage. Basically, there is a 4 megabyte DDR3 stick on the PCB here. And here is the 6-pin debug port. So after a little bit of investigation, I managed to find the ground pin and also the transmit port of that serial debug interface. So that basically means with these 2 connectors here, I should be able to hook up my computer and see if I can get some serial output from this thing. So I have this, USB to serial converter, and I just hooked up the ground connector. And on this USB device, I used the RX port so that I'm able to receive data from that serial port. I won't be able to write to that serial port, so I won't be able to enter commands, but I should be able to read off of that serial port. And the reason is that this device, the Synology device, uses a 1.8 volt or 3.3 volt serial port connector, and this is a 5 volt device, so I don't want to risk damaging something. So I'm just going to be reading off of the thing. So yeah, to read data from the device, all you need to do is set up a serial communications program. I'm using the USB serial here, set the baud rate to 115,200, and then just connect and see if something will appear over the wire. But unfortunately, I wasn't able to get anything off of that serial output. What I did notice is that when I removed the Synology DDR3 module here, which came standard with the device, and I replaced it with another 4 gigabyte stick from a laptop, because I figured, might be an issue with the RAM or something. I don't know. I read somewhere on a forum that somebody had RAM issues with his Synology device. And as soon as I hooked up my serial connector with this RAM stick, I did get output on the serial port. So that basically means that the serial output is working, that the machine is not completely dead, and that I should be able to start further investigating. Now, it is saying memory training failed in a dead loop, so this might be the RAM stick which is not compatible, and the fact that it does work with, or that there is no output with the Synology RAM, means that there might be another issue. So still not clear what the issue is, but let's get the PCB out of this aluminum frame so that we can take a closer look at what is on the other side of this PCB. And what we have here are 2 connectors for hooking up some DDR3 memory. We have some connectors for the SATA, for the USB, and one chip of interest here on the backside of this PCB is this WinBond chip here, which should contain the BIOS of the device. So this type of chip, this WinBond chip in particular, is used in many motherboards, video cards to contain BIOS information. Now we should be able to read the content of this flash memory chip. I initially tried it with an alligator clip like this, which allows you to hook it up while the chip is still attached to the PCB. But with my programmer, I wasn't able to read the data from it. I got this check ID error. And what this usually means is that something is interfering with the chip, probably because it's still hooked up to the PCB. Sometimes the check ID is masked by the vendor, but in this case, I'm guessing it's not, because when I disabled the ID check and I tried to read the flash memory, all I got back were zeros. So yeah, I'm not thinking that this Synology is so screwed up that the flash memory contains only zeros, so that definitely cannot be the case. So that's an issue with these alligator clips. And I'm not really a fan of these things because, you know, doing these kind of in-circuit testings is always a bit tricky. And also the quality of these alligator clip differs a lot. I mean, the plastic here got eroded very quickly, and after a couple of tries, I wasn't able to clamp it onto the chip anymore. A much better solution is to just desolder the chip from the PCB and hook it up to one of these SOIC 8 to DIP 8 converters like you're seeing here, and then trying to read the chip. And with that, I was able to read the chip. Now the check ID got detected and I was able to read the content from the flash chip. Now, what is actually on a flash chip like the one on the Synology? Well, we have 16 megabytes worth of hexadecimal data that you can look at here. And this is basically what I found on the Synology NAS. Now, the thing is, we want to make sure that this is somehow not corrupted, and we need to compare it to an actual BIOS ROM that we can download from Synology. Now, a hex editor can help you kind of interpret what kind of byte structures or patterns are in here. Sometimes the bytes can be translated into readable text, so having a good hex editor is definitely key here, allowing you to not only visualize the content of a file, but also do comparisons with other files. Now, sometimes what you also see in these files is that they contain padding. So at the end of the file, you either see all zeros or all FF bytes. Now, I also downloaded an official BIOS ROM from the Synology site just to compare it with the one that I dumped here. And there were a couple of differences here. First, I mean, the overall size of the files was already different, but there were definitely some patterns that we could recognize in both files. The difference being that these patterns were in different positions in both files. So we needed to sort that out. So let's take a closer look. So if I select the first couple of bytes from the thing that I dumped from the Synology, you can see the same pattern emerging from the downloaded BIOS ROM file from the Synology site, only they are at a different position. So it's a matter of finding the correct offsets in the downloaded Synology BIOS ROM and see how they match up with the one that I downloaded from the actual NAS box. And then it's just a matter of kind of reconstructing a new BIOS file just based off of those offsets. So for example, here in the BIOS ROM file that I downloaded from the Synology site, if I go to a certain offset, which I'm going to be doing now, you can see that the pattern that starts to emerge here is actually the beginning of the file that I downloaded from the NAS box. So everything above that can basically be cut. And the same goes for the bottom part of the file. So it's just the thing is that the file that I downloaded from the Synology site has this kind of header or footer that can be stripped, and then you end up with hopefully the correct BIOS ROM that you can flash again on the Synology box. Because here you can clearly see that the pattern is identical, and if I cut the header off of the BIOS ROM and find the end of the file, I should be able to reconstruct that. And after I was done with, cutting the head and the tail off of that file, I got a pretty good comparison here between what was originally on the NAS box and what I have now flashed again. And it all looks pretty similar, but there are a couple of bytes different here and there. So obviously something got corrupted along the way. And here you can kind of clearly see that, about 98% of the file is identical, but just here and there, things got kind of screwed up. So yeah, just time to reflash the NAS box and see what it does, I guess. So that's what I ended up doing, and I reflashed the flash chip here and I put it back on the PCB, as you can see here. So now the moment of truth, let's start her up and see what she does. We again see the blinking blue LED, which is normal for a Synology NAS. It always starts out this way, but hopefully after a couple of seconds, we should be able to hear a beep, which is the normal startup procedure of a Synology NAS, and not have this blinking LED going on indefinitely. So yeah, was pretty anxious to see what the thing would do, but then after a couple of seconds, the following happened. The blinking blue LED stopped, we heard the beep sound, and it would appear that the Synology NAS was actually started. So yeah, that's really, really good. I wanted to verify that, so I hooked up my USB to serial device again. So I hooked up the ground connection and the receive pin here on the debug port of the Synology NAS. I hooked up my laptop and I wanted to see what kind of output I got now from the serial port. So I turned on the Synology NAS and went to my laptop, used a serial program, just connected to the serial port, and lo and behold, all of a sudden I saw the Synology NAS booting into its operating system, which obviously is Linux based. And it just went through its startup procedure like, nothing ever happened. Everything was appearing to run fine. After a while, I got this login prompt. I also hooked up an Ethernet cable. It was able to get an IP address from the DHCP server. So yeah, everything seems to be running fine, which is really, really good. And because it was able to get an IP address, I could also access it using my browser. So when I went through the IP address here, I got the Synology web assistant. Obviously, it's not loading because there are no hard disks attached to the NAS box at this moment, but this is already really good. It means that it's up and running. It was able to boot its operating system. So yeah, everything was running fine at this point. So I guess it's now time to put everything back together. Now, before I started to put everything back together, thought it would be a good opportunity to clean it a bit. Like I said earlier, this has been running non-stop for over 3 years, so there is a little bit of a dust buildup. So yeah, now's an excellent time to go ahead and clean everything up before we put everything back together again. So yeah, really excited about the fact that it seems to be up and running again. Let's hope that it will still be the case after I put everything back together again. So let's start the process now. So yeah, we again got the beep, meaning that the NAS box was able to boot. The status LED is light up, as well as the 4 disk LEDs, so everything seems to work. The blue LED is fixed, so we can now access our NAS box using the web-based console. We get the login prompt, which is already good. I should be able to use my existing credentials because I guess they are stored on the hard drives themselves, because the disk station management is in fact installed on the hard drives. And I am able to log in and access the NAS box without any issues. So yeah, seems like the issue is fixed, which is really good. I was able to see and access all of my files without any issues. So yeah, pretty happy with that. But you know, despite the fact that we were able to unbrick this Synology NAS here, I am left wondering why on earth is it possible for a pretty expensive NAS box like this one just to fail so horribly after a simple power cut. I mean, there should be a more easy and non-intrusive way to fix this, right? I mean, there are lots of people that have similar issues, and for them, the only issue is basically just to get a new NAS box, and that's just simply not acceptable. I think Synology should have done a better job here in making sure that there is a procedure to fix this, because after all, this is like $500 US, so it's not exactly cheap. But anyways, just wanted to talk about this a little bit, so I hope you've enjoyed this video. If you did, please consider giving it a thumbs up. Feel free to provide a comment in the comment section below. Subscribe to the channel if you haven't already done so, and I hope to see you guys in the next one. Bye bye.